Welcome to the DIY Honda Garage channel. In this presentation, we will discuss the DTC P0335, which indicates a CKP sensor no signal error in the Honda Accord models from 2017 to 2023. The crankshaft position, CKP sensor, plays a crucial role in the engine's operation by sending information about the crankshaft's position to the powertrain control module, PCM. This signal is vital for optimal engine timing and fuel injection. The CKP sensor is typically located near the crankshaft, and any disruptions in its signal can lead to engine performance issues such as stalling or difficulty starting. We will explore the causes, symptoms, and a step-by-step troubleshooting process necessary to address the issue effectively. DTC P0335 signifies a no-signal condition from the crankshaft position CKP sensor to the powertrain control module PCM. The CKP sensor is essential for monitoring the position of the crankshaft, which aids in determining the timing for fuel injectors and ignition coils. If this sensor is not functioning correctly, various engine performance issues can arise, including hard starting or stalling. The CKP sensor is usually situated at the crankshaft, making it relatively accessible for diagnosis and replacement. Understanding its role and location can significantly aid in troubleshooting the issues related to this diagnostic trouble code. Several factors can lead to the P0335 error code. A faulty crankshaft position CKP sensor is a common cause. If the sensor itself is malfunctioning, it won't send the necessary signals to the PCM. Additionally, poor electrical connections, such as corroded terminals or loose wiring, can interrupt the signal and also prompt this DTC. Furthermore, an internal failure within the PCM can also be a reason, although it is less common. Verifying these components through systematic testing is essential for accurate diagnosis and repair. The symptoms associated with DTC P0335 primarily revolve around the vehicle's engine performance. Drivers may experience engine stalling, particularly under acceleration or while idling, indicating that the CKP sensor may not be providing accurate position information. Additionally, difficulties starting the engine could occur, potentially leading to frustrating delays. Increased fuel consumption is another symptom, as improper timing due to the CKP sensor failure can lead to less efficient fuel usage. Observing these symptoms closely can help in diagnosing the root cause effectively. The first step in tackling the P0335 error involves verifying the problem. Begin by turning the vehicle to the on mode without starting the engine. Once in on mode, clear the existing diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. It's crucial to perform this step to reset the error codes that might be logged. After clearing the codes, start the engine. Upon starting, it will be important to check for any pending or confirmed DTCs using the HDS once again. This will help determine if the issue still persists, allowing the technician to take the next required steps based on the outcome. In the second troubleshooting step, turn the vehicle to the off/lock mode and disconnect the CKP sensor's 3P connector. This disconnection is critical to isolate the CKP system and evaluate its electrical integrity. After disconnecting the sensor, switch the ignition back to the on mode while making sure that your vehicle's engine is still not running. Now, measure the voltage between test points 1 and 2, specifically the female terminal number 3 of the CKP connector and body ground. The expectation here is to find approximately 5.0 volts, as this indicates that the vehicle control circuit, VCC1, is supplying power correctly to the CKP sensor. For troubleshooting step 3, It's important to ensure that the vehicle is turned off. Lock. Jump the SCS service check socket line using the HDS for over 1 minute to allow any inaccuracies in the system to clear. Following this, disconnect the PCM's connector E, ADP. After successfully disconnecting both the CKP sensor and PCM connectors, you'll need to check for continuity between test points 1 and 2. Test point 1 connects to female terminal number 3 at the CKP connector, while test point 2 correlates with PCM connector E's terminal number 70. If continuity is found, the VCC1 wire is intact, and the next steps can involve checking other areas, or it might be necessary to review available service information or test with a functioning PCM. In Step 4 of the troubleshooting guide, we will determine the integrity of the CKP line. Begin by measuring the voltage between designated test points while ensuring the vehicle is in the on mode, and the CKP sensor 3P connector remains unplugged. Test point 1 should correspond with female terminal number 1 at the CKP connector, while test point 2 will be body ground. The expectation is again to see about 5.0 volts. If this voltage is present, it indicates that the system delivers sufficient power to that circuit. If the voltage measurement fails to meet expectations, it suggests further issues within the wiring that will require attention. As we move to Step 5, we will focus on examining the SG1 wire's functionality. Measure the voltage between test points 1 and 2 while keeping the CKP sensor 3P connector disconnected and the vehicle in on mode. Test point 1 should relate to the CKP connector female terminal number 2, whereas test point 2 pertains to female terminal number 3. We should again expect to see around 5.0 volts. A successful voltage reading suggests that the SG1 wire is operational, thus indicating that attention should shift to replacing the CKP sensor itself if this has not yet been addressed. During the 6th troubleshooting step, we will assess the integrity of the SG1 wiring. First, switch the vehicle to off, lock mode, and then jump the SCS line using the HDS for a minute. Disconnect the PCM connector E, ADP, as this is necessary to evaluate the wire connectivity properly. Measure continuity between test points 1 and 2, with test point 1 being female terminal number 2 of the CKP connector and test point 2 being number 271 of the PCM connector E. Successful continuity indicates that the SG1 wire is intact, prompting further considerations such as consulting authorized service information for related DTCs or testing with a known good PCM. In Step 7, we will conduct a shorted wire check for the CKP line. As with previous steps, begin by switching the vehicle to off, lock mode. Then jump the SCS line through the HDS and wait for a duration of more than 1 minute to stabilize the readings. Disconnect the PCM connector E, ADP, yet again to ensure proper electrical isolation. Finally, assess continuity between the designated test points, which consist of terminal number 44 of the PCM connector and body ground. Detecting continuity indicates a short in the CKP wiring, suggesting that repair is needed to restore appropriate function. The 8th and final troubleshooting step involves conducting another continuity check, this time focused on the CKP line. Ensure that all conditions are still met, with the vehicle in off mode and the CKP sensor 3P connector disconnected. Measure continuity between test points 1 and 2, with test point 1 being female terminal number 1 of the CKP connector, and test point 2, terminal number 44 of the PCM connector E. If continuity is found, The wiring between the PCM and CKP sensor is intact, suggesting the next steps may involve other diagnostic information sources or replacement of the PCM. However, should continuity fail, it is imperative to repair the open wire to restore the circuit's functionality. Following all troubleshooting steps for DTC P0335, it's crucial to perform a final repair verification. Begin by securely reconnecting all electrical connectors that were previously disconnected during the troubleshooting process, including the CKP sensor and PCM. Once all connectors are in place, utilize the HDS to clear the diagnostic trouble codes, DTCs, once more, to ensure no lingering codes affect operation. Finally, conduct a test drive to observe whether the engine operates smoothly and to confirm that no new DTCs are triggered after the repairs. This comprehensive approach ensures that the problem has been effectively resolved. To prevent future occurrences of DTC P0335, it is advisable to incorporate regular maintenance practices. Regularly inspecting electrical connections and wiring for signs of wear or corrosion can significantly reduce the risk of CKP sensor failures. Furthermore, routine checks of sensor functionalities can help identify issues before they escalate into significant problems. Scheduling periodic diagnostic checks can keep vital systems in check and enhance overall vehicle reliability. Following these preventive measures will help maintain optimal vehicle performance and minimize unscheduled repairs. In conclusion, the DTC P0335 indicates a CKP sensor no signal issue that can significantly affect vehicle performance. Understanding the critical function of the CKP sensor is vital, as it impacts fuel injection and ignition timing. A systematic troubleshooting approach ensures that all potential causes are explored thoroughly, allowing for precise diagnosis and effective repairs. Finally, embracing preventive maintenance practices is essential for sustaining vehicle health over time. By prioritizing these aspects, Honda Accord owners can enjoy reliable performance and minimize the risk of future DTC occurrences. Please like and subscribe to the channel. See you next time.